Alright, so our lesson today is going to be section 1.9, and this is day 3. And we're going to be looking at multiplying and dividing rational expressions. And so we're going to kind of take everything that we've learned up to this point throughout this portion of the unit, and we're going to kind of keep it all together, and we're going to look at different things from factoring. We're going to look at different things from canceling factors and doing all these different things that we've already kind of done up to this point. And so if we look at this, we've kind of already dealt with simplifying rational expressions before, where we would factor the top, we would factor the bottom, and we would look at what they have in common, what they don't have in common, so that we could cancel certain things out. And I told you before that you can cancel, that you could cancel factors, but you can't cancel terms. And so when we look at something like this, we can't just find a 2 and cancel it with a 2. We have to be able to factor this before we can start canceling. So as we did before, we looked at something like this. This is a quadratic, and in order to see if this simplifies at all, we need to factor this. So again, we would use that A times C method, and we could look at the factor pairs of 2 that would combine to give us 3. And if we were to factor that out, that would give us x plus 2 and x plus 1. Where 1 times 2 is 2, and then 1 plus 2 gives us the middle term of 3. Now we can do that same thing at the bottom. Now this doesn't have an x squared, so we know that it's probably not a quadratic at all. And so we can find the greatest common factor, which the greatest common factor there is 2. And then we have x plus 2 left over after we remove that factor. Now the idea here is that we're just canceling the factors. And so we see that we have an x plus 2 and an x plus 2. Those cancel out. Our simplified expression is x plus 1 over 2, where we had restrictions that x could not equal negative 2. So we always kind of still look for those restrictions whenever we could. So the idea here is that we're just simplifying these rational expressions and still using that factoring. Now we're just going to add one more element to this by multiplying these, and it's really not going to work too much differently, as we'll see in a few examples here. Now the thing that we have to remember is multiplying our fractions. Now there's a way that we can just multiply fractions. I like to call this a straight across method, where all we're going to do is we're going to just multiply numerators, multiply denominators. So if we do this, we get 35 over 72. And then I would look to see if there's anything that's in common with these things here that we could cancel them out. Now there is another way that we could do this, and I'll show this to you on the second one here, is that we can cancel before we multiply. Now some of you might know this as cross-canceling, not cross-multiplying. Cross-multiplying is something completely different, but some of you might know this as cross-canceling. And so what we could do is we could kind of cancel these things or simplify this before we multiply. So we're going to simplify before multiply. And so the idea here is that we could look on the diagonals. And so if I look on the first diagonal, we have 3 and 15, and we have 3 and 25. So what I could say here is that 3 goes into 15. There's a common factor there of 3. So I would say, okay, 3 goes into 3 one time, and 3 goes into 15 5 times. And so now what I've basically done is I've created 2 new fractions that now I can see if there's anything that's on the diagonal that I could cancel, or underneath that I could cancel, and there's not. And so the idea is now I can just go ahead and multiply 3 over 125. So the idea is that you can simplify before you multiply, and it makes the process just a little bit easier. And we're going to take this kind of same process and apply this to rational expressions. And so just so that we're aware of this, the rule of multiplying algebraic fractions, it's the same as multiplying what we call numerical fractions. And so if I give you this example, a over b times c over d is simply just a times c over b times d. And so what we're basically doing is we're just multiplying straight across. There's not anything that we have to worry about, but then at the end we just need to make sure that there's nothing that we can't simplify. And so how does this work with what we've been doing? So again, I've kind of already outlined that before, but at least let me show you this to you here. So here I've given you this algebraic fraction. And we call it a rational expression too as well, that we're multiplying with variables and things like that. So the first thing that we're going to do is we're going to try to simplify by factoring if possible. These are all monomials in each one of these positions, and so there's not anything else that I can do. Now if this was multiple terms, I would try to factor it with the greatest common factor, or if it was a quadratic with 3 terms, then I would try to use my product of 2 binomials where I have the x plus x minus kind of stuff. And then I'm going to reduce as possible. So a little bit we're going to have to remember some of our exponent rules. And so whenever we divide these things, what we're doing with them, or what's another way that we can look at these. And then once we factor, once we reduce, where we're canceling out those common factors from the numerator and the denominator, then we can just go ahead and kind of lump these together and just say, okay, multiply these numerators, multiply the denominators. Once I do that, I can go ahead and I can combine like terms. So if there's anything else that I have that I can add together or anything like that, then I'll go ahead and do that, because maybe we might have a situation in which we need to distribute, and I'll show you some of those examples as we go by. And then finally, our last step here is to simplify the denominator by combining like terms. So after I'm done with that and I've got everything reduced and I've got everything done, then I can start to distribute, or if I need to FOIL after I'm done, because remember, we always try to write this in its FOILed form rather than its factored form. So let's take a look at this example. So there are a couple different parts at play here. So the first part that we have to kind of look at is that we have our values, we have our variables, and we also have kind of our numbers. So if we look at these, we have an A and we have an A down here, and we have a B and we have a B up here, and then everything else is just kind of numbers. So when we look at something like this, what I want to make sure that I can do first is that I can factor this, or then I can start to cancel things out. And so when I look at this, the immediate thought is cross canceling or simplifying before we multiply. So we're going to look at certain things, and we have b squared and we have b to the 4th. So technically speaking, we have b times b times b times b, and then down here we have b times b. Now the whole idea of what's happening here is I'm canceling 2 b's and I'm canceling 2 b's, and I have 2 left over. So this is just kind of the same idea here. Now if I wanted to look at it another way, I could say b to the 4th divided by b to the 2nd gives me b to the 2nd, because I'm subtracting their exponents. But the idea is that we have to look at how many we have and then how many we can cancel away from each other. Now when I have a to the 3rd divided by a, one a cancels one of these a's and I'm left with a to the 2nd. And so that's one way that we can kind of go about this. And so what we're doing is we're going to say b to the 2nd cancels out b to the 4th with 2 b's left over. Now if I was to do the numbers here, and I cross-canceled numbers, 5 and 20 have a greatest common factor of 5. 5 goes into 5 one time. 5 goes into 20 4 times. And then I can do the same thing with the other diagonal. 6 and 18 have a greatest common factor of 6. 6 goes into 6 one time, and 6 goes into 18 3 times. Now this seems like a lot of what I'm doing here, but what I'm doing is I'm canceling out these different factors. So anything that's multiplied together, remember, is a factor. Now there is no addition here, so we don't have to worry about things being terms. And so what I'm left over with, if I rewrite my new fraction, is 3a to the 2nd over 4 times 1b to the 2nd over 1, because everything in that denominator canceled away. So the idea of what I'm doing here is I'm trying to eliminate certain factors, certain variables, so I can kind of cancel them out in groups. Now I can go ahead and just multiply across. 3 times 1 is 3. A to the 2nd times b to the 2nd, those aren't like terms, so I don't have to worry about changing their exponents. And then 4 times 1 is 4. So that in a nutshell is kind of what we're doing here. So we're looking at an algebraic fraction. We're canceling like factors from the numerator and the denominator, kind of canceling those pairs, and just simplifying it, and then we can multiply it. We don't want to worry about trying to multiply and then figure out what we can cancel or anything like that. The idea is it's easier if we simplify rewrite it, and then multiply it at the end. And so there's our first example. Our next example is probably a little bit easier to see because there's not as much stuff going on, but it's just a little bit different in terms of the way that it works. So we have 2x plus 4 over x multiplied with 3 divided by 6x plus 12. And so if we remember that first rule that we kind of wrote down a few slides ago, is that we want to factor with the greatest common factor or factor the quadratic. And we're going to go through each one of these pieces and do that. So if I look at this first piece, we have 2x plus 4. The greatest common factor there is 2. And what's left over? X plus 2. And then divide that by x because there's nothing that we can factor there. It's just a plain x. And then that's multiplied by 3. 3 is kind of by itself. And then at the bottom we have 6x plus 12, which we can see that that has a greatest common factor of 6. And then what's left over? X plus 2. And so now that we look at this, now we have our new multiplication problem. We didn't do anything to our multiplication problem other than just kind of rearrange some things and make it look a little bit different. And so now when we look at the diagonals, I can say to myself, okay, is there anything that I can cancel there? Is there anything that I can work with? Well, what we have is we have this x plus 2 and this x plus 2. And so what happens to those is those cancel each other out, because they are similar factors. And so this isn't no different than that very first example where we canceled something from the numerator and canceled something from the denominator. It's still going to work that way. And so if we rewrite our fraction after we cancel those and we just multiply across, we have 2 over x times 3 over 6. Now I also see something else that I can simplify, but let's write this a little bit differently. Is if I looked at the diagonal here, greatest common factor would be 2 and 6, or between 2 and 6 is 2. 2 goes into 2 one time, 2 goes into 6 3 times. Rewrite my multiplication, 1 over x times 3 over 3. Well, 3 cancels 3. Doesn't have to necessarily be cross-canceling to be able to cancel stuff out. As long as it's in the numerator and the denominator, it'll cancel out. And that becomes 1 over x times 1 over 1, because 3 goes into 3 once, and 3 goes into 3 once. I messed up here. This should just be a 1. And so when I multiply that out, I just get 1 over x. And so there's my final simplified answer. Now, of course, we still do have restrictions. My restrictions of x is x cannot equal 0 and x cannot equal negative 2. Now remember where I get that from. I get that from up here. So this x by itself and this x plus 2 over here give us our two restrictions because we can't have those equal to 0. But the idea there is I just went through a process. I was factoring some things out. I find some common factors that were in the numerator and the denominator, cancel them out, simplify, keep going, cancel, simplify, cancel, simplify. And that's just the process that you're going to go through to complete these particular problems. Now if we look at a little bit more complex problem, this one's going to involve a few more steps here. And so the idea is that I need to factor this as much as possible. And so a plus b is already factored. There's no common factors between those. A is already factored because it's just by itself. A times b is technically factored because it's kind of already there. There's just a times b. Now the only thing that we have to worry about here is this a squared plus 2ab plus b squared. Now this is one of these things that we call an identity. And if you remember, this comes from something that we did earlier called a plus b to the power of 2, and if we FOILed that out, gave us a to the second plus 2ab plus b squared. So the idea is that we need to identify this as what we call a perfect square. And I wrote that really terribly, sorry. So this is a perfect square. And perfect squares will always have this particular formula here. And so whenever you see something like this, you're going to have two of identical factors here. And so if we were to factor this out, we would have a plus b over a times ab divided by a plus b times a plus b. Now the idea is that what two factors of b squared would give you 2ab, and so it takes a little bit of thinking, but we want to at least look at this in terms of what we call an identity. And it's just something that you want to get in the habit of recognizing because it just makes your factoring a little bit easier. But the idea here is that we have a plus b over a times ab over a plus b times a plus b. And so we can look at those and kind of look at these in terms of factors, and then two of these will cancel each other out. Now also with that, this a will cancel this a. And anytime anything cancels completely out, remember it always reduces to a 1. So what's left over in our numerator is just 1b over 1 times a plus b. And then here's something where we can just kind of eliminate those 1's, and we have b over a plus b. And so the idea of what we're looking for is we're just looking to factor so that we can cancel out and make our multiplication just that much easier. Now our final thing here is now we're going to move on to dividing rational expressions, and dividing rational expressions is really easy because it's already something that we've already done. There's only one rule for dividing rational expressions, and it's kind of a quick thing, and it's called multiplying by the reciprocal. So the idea is that we can take division and turn it into multiplication by taking the second fraction and flipping it upside down. So we're going to take those that second fraction and just flip it upside down and turn my problem into a multiplication problem. And so this is what this would look like. The first one stays the same, x plus 4 over 2x minus 6 multiplied by 4x minus 12 over 3x plus 12. And so the idea is that I'm just taking that multiplication problem, or that division problem, and turning it into a multiplication problem, and that's something that I've already been working with so far. And so now that I have my multiplication problem, we can take a few extra practices here and we can go through this. So now we're going to look to factor these particular polynomials. So the first one stays the same at x plus 4 divided by 2x minus 6 has a greatest common factor of 2. Left over is x minus 3. Multiplied by 4x and negative 12 have a greatest common factor of 4. Left over x minus 3. And then divided by 3x plus 12 has a greatest common factor of 3. And then we can say that what's left over is x plus 4. Now if you notice, whenever we kind of do these things, it kind of sets up to where our factors are kind of already there for us. And so that we see an x plus 4 and we can cancel it with an x plus 4. We see an x minus 3 and we can cancel it with an x minus 3. And then what we see is we see a 2 that can cancel with a 4, and that becomes a 2, because we know that 4 divided by 2 is 2, or the greatest common factor between those is 2. 2 goes into 2 one times, 2 goes into 4 two times. Now that I have this all simplified, I just have a basic fraction that's left over. Everything canceled from the top over here, so I'm left with 1 over 1 times 2 over 3, which just simplifies to 2 over 3. Now the idea is that this entire fraction simplified to 2 over 3. The only thing is that we have restrictions, is that will always happen so long as x is not equal to 3 and negative 4. And where did we get those things from? Well, remember we got it from these denominators here. We had the zeros of that denominator were positive 3 and negative 4. So the idea with the division, it's the same thing as multiplication, but we just need to remember that we have to multiply by the reciprocal. We're multiplying by the reciprocal. And so let's take a look at our final example. Our final example is a little bit tough, but we can kind of work our way through this. And so the first thing is that I see this as division. I want to change to multiplication because I love multiplication and it's a lot easier. So I'm just going to basically take this fraction, flip it upside down. So I get x squared plus 3x minus 40 over x squared plus 2x minus 35 times x squared plus 3x minus 18 divided by x squared plus 2x minus 48. Now the trick here with this particular problem is that I have 4 different quadratic expressions, which are going to require me to have 4 different pairs of binomials. And so I'm going to have to go through this and find the factor pairs of C that give me B. And so it's going to take a little bit of a process. So, there's some things that we can make a little bit easier. And so if I start over here, and I can get rid of this stuff here, one thing that I can make this easier, and it kind of helps me with this, is you look at C. And as I look at C, every C in this particular situation is negative. And then I can look at B. Every single B in this particular situation is positive. So already what I can tell is that all my fractions are going to start the same way, or all my binomials are going to start the same way. So I'm going to have x plus something and x minus something in each one of these situations. And so what I'm doing now is I'm just simply setting up my binomials, because I know what they're going to look like. I know that they're going to have each one, or at least one positive and one negative. And so I can just go ahead and I can just start getting my parentheses or my binomials ready. And I can kind of take these one at a time. And so there are going to be a little bit of steps that I'm going to assume that you already know what to do with. But we're going to kind of take this a little bit at a time. So the first one is 40. So we're looking for factor pairs of 40 that are only 3 values apart. So the reason that I'm telling you that they're apart, not adding together, is because it is subtraction. And so the factor pairs of 40 that are 3 values apart are 5 and 8. And since the middle number is positive, I know that the larger number needs to be positive. And so this is going to be x plus 8 and x minus 5. Now if we can check that real quick. So 8 times negative 5 is negative 40. Positive 8 minus 5 gives us positive 3. And so that we know that's the right combination. Now we're going to move on to the next one. We're going to look for factor pairs of 35 that add and subtract or have a difference of 2. And those ones are 5 and 7. Now I know since B is positive, the larger of the two needs to be positive. And so it's going to be x plus 7 and x minus 5. Now already you might be able to see that we have a factor pair here and a factor pair here that are identical to each other, and that's good. So we're recognizing that we have these factors that we can cancel. However, we're going to wait until we have all of these done before we start canceling things out. So the next one, factor pairs of 18 that have a difference of 3. Well, that's 6 times 3 gives us 18. The larger number needs to be positive since B is positive. So that's x plus 6, x minus 3. The next one, factor pairs of 48 that are only 2 values apart. Now this one is 6 and 8. So 6 times 8 is 48. Again, B is positive, so the larger number needs to be positive. So we end up with x plus 8 and then x minus 6 at the bottom. Now this is where it gets a little tricky, because now we see something that's x plus 6 and we see x minus 6, and it's not going to work out the way that we want it to, and that's okay. They don't have to necessarily be the same, and even though we want to cancel those out, it's okay that those aren't going to work out that way. So when we look at these, we're going to cancel before we multiply, or what I said before is we're going to simplify before we multiply. And so what we can do with this is we can look at those factor pairs that are the same. So we have an x plus 8 here that cancels, and an x plus 8 here that cancels. Now, before I do cancel, I just want to warn you, it might be a good idea to look at our restrictions first. And our restrictions are everything that's in the denominator. So x cannot equal negative 7, positive 5, negative 8, or positive 6, and that's where we get each one of these from. So just make sure that you're identifying those restrictions before you start going crazy with your canceling, like I almost did. And so the other pair that we can cancel is going to be x minus 5 and x minus 5. And so with that, we're going to have some stuff left over here. And so what we have left over in the top is we have x plus 6 times x minus 3. And since these are being multiplied together, I can just say, well, this is x plus 7 times x minus 6. And so there is my simplified rational expression. Now, the last part of those steps was, I think, step 6. Told you that we need to simplify this now. So we're just going to go ahead and we're going to FOIL this out. So we get x squared plus 3x minus 18 divided by x squared plus 1x minus 42. And then that is our simplified expression. So the idea there is that we're just going through our process. Now if we kind of look back at that and we kind of see what we were doing before, is we just have to make sure that we're going through our steps, factoring, looking for greatest common factor, looking for binomial factors, and then going through the process of canceling them out. So just making sure that you keep things going and you understand the whole idea of factoring and canceling out factors and not terms, then everything should be okay. And that's going to do it for this video.